Robot rampage at restaurant. Dancing robot goes rogue at Haidilao Hot Pot. Chaos at the table. A routine dining experience turned into an unexpected spectacle where a dancing robot at a Haidilao Hot Pot restaurant in California appeared to go out of control, smashing dishes, knocking over utensils, and startling customers. Now let's dive deeper and explore every layer of this story on our AI podcast.
When you sit down for a meal at a nice restaurant, there's this very specific, unspoken social contract,
Oh, absolutely.
like a contract about the physical space around your table. You expect a certain choreography from the staff.
Right. The servers know exactly how to weave around the chair.
Exactly. The bus staff anticipate where the blind spots are if you suddenly lean back. Everyone just sort of subconsciously understands that invisible boundary of your personal dining space.
Yeah, it's a highly fluid, really intrinsically human environment. There are hundreds of micro adjustments being made every single minute by everyone in the room.
And we take all of that background processing completely for granted until, something disrupts it. And when you introduce a piece of heavy automated machinery to that delicate dance floor, that social contract doesn't just bend, it completely evaporates.
It really does.
So today we are taking a deep dive into an incident report from a Haidilao Hot Pot restaurant in California.
Yeah, pretty wild story.
And we're combining that with a broader spatial computing analysis by tech journalist Joanna Stern.
Right.
We're taking these sources to break down a dining experience that went spectacularly off the rails. We really want to understand what happens when hardware engineering just, completely ignores the realities of human environments.
Yeah, and what's fascinating here is that our goal today isn't just to gawk at a viral video of a robot failing.
Right, as tempting as that is.
I mean, it's visually absurd as the incident might be. We are looking at this through the lens of systems design. We want to unpack the very real, very kinetic friction that occurs when advanced automation is dropped into spaces it fundamentally does not understand.
Yeah.
This is really a case study in the danger of deploying blind kinetic energy into shifting human spaces.
Okay, let's unpack this.
Yeah.
Because the physical reality of what happened at this restaurant is genuinely startling.
It's chaotic.
To say the least. I want to paint the picture for you based on the incident report. So imagine you are sitting down at this Haidilao location.
And for context, a hot pot restaurant isn't your standard dining setup.
No, not at all. You have a massive, literally boiling pot of incredibly hot, oil-based broth integrated directly into the center of your table.
It's a high-stakes environment.
Exactly. People are constantly reaching across, dropping ingredients in, fishing them out. It's an active, very dynamic dining experience.
Right.
And Haidilao is famous for pairing this with futuristic entertainment. So you're expecting a dinner show, right?
Yes, some fun novelty.
But then a dancing robot approaches your table, and instead of a smooth, programmed routine, this machine suddenly begins violently pounding on the table structure.
The kinetic force described in the report is, it's significant.
Yeah.
The machine begins striking the table surface repeatedly, just mere inches away from where customers are actively managing boiling liquids.
Oh, it's terrifying. And it wasn't a subtle glitch either. It wasn't like a screen froze or a speaker looped a song.
No, nothing like that.
The report details the robot's arms launching chopsticks into the air, shattering plates, and just scattering food debris all across the dining area.
I mean, the customers were frozen. Just watching this heavy machine turn a relaxing meal into a completely messy hazard.
And the immediate response from the restaurant staff, that is where our source material gets highly illuminating regarding the engineering flaws.
Right, because they couldn't just tap a touchscreen.
Exactly. There was no simple pause button to hit.
The situation instantly escalated from a technical glitch to a literal physical struggle between human wait staff and automated machinery.
Yeah.
You have these staff members who are trained in customer service and food handling, suddenly forced to act as emergency industrial mitigators.
The report explicitly details how one or two servers initially tried to restrain the robot's limbs, but the torque of the machine's motors was just too strong.
They were physically overpowered.
Completely. It eventually took 3 separate staff members to gain any sort of control.
3 people.
And the method they had to use is incredibly revealing. They had to locate a specific fabric strap attached to the robot's chassis and engage in a literal tug-of-war to drag the heavy base backward.
Oh, still moving.
Right. All the while, the robot's programming is continuing to fire. It's shuffling, its arms are flailing, completely oblivious to the fact that 3 adult humans are fighting its motor output.
And, the physical resistance the staff encountered points to a lack of what engineers call back drivability in the motors.
Back drivability.
Yeah. In collaborative robots, or cobots, designed to work alongside humans, the joints are typically designed to yield when they encounter unexpected physical resistance.
Oh, okay.
So if a human pushes against the arm, the motor gives way to prevent injury.
Makes sense.
But the fact that 3 people had to haul this machine away by a strap indicates these motors were aggressively holding their programmed positions. They were fighting the human intervention every single step of the way.
Wow. It's like a mechanical bull in a china shop, but specifically a mechanical bull that's been programmed with a highly rigid map of an empty room.
Right. It assumes the room is empty.
It doesn't know the china is there, and it certainly doesn't know a customer is there because its internal systems are completely blind to anything outside its hard-coded X and Y coordinates.
Exactly.
It is just blindly executing code, forcing its physical mass through the space, regardless of the resistance it meets.
And that mechanism you're describing, that blind execution of code, is really the crux of the issue. It forces us to examine the massive chasm between the glossy corporate pitch of automated service and the messy reality on the floor.
Oh, yeah.
Brands invest in these machines expecting a frictionless sci-fi aesthetic. But when the kinematic energy meets an unpredictable human space, you suddenly have waitstaff wrestling a machine.
It's absurd.
It is. The sources prompt us to ask how regulatory frameworks are even allowing machines with this much blind torque to operate within inches of unprotected consumers, especially without specialized staff training.
And naturally, when you hear about a machine aggressively pounding a table, ignoring human resistance, requiring 3 people to physically drag it away.
They assume it broke.
Exactly. The immediate assumption is a catastrophic software failure. You assume the operating system crashed, the sensors fried, the robot went completely rogue.
Right.
But the actual explanation provided by the company is far weirder. And their defense of the machine's behavior opens up this massive debate about design philosophy.
Yeah, Haidilao issued a definitive statement pushing back against any narrative of malfunction. They explicitly stated the robot did not go rogue.
Wait, really?
Yeah, they said the hardware was operating exactly as intended.
According to the source, the company claimed the robot's physical movements were entirely pre-programmed. Their official explanation placed the blame squarely on spatial constraints. A customer had apparently requested the robot be brought closer to their table for the performance, and Haidilao's statement read, "The limited space affected its movement during the performance."
So they essentially categorized this aggressive table smashing as a simple user error.
Which is wild.
The robot was in the wrong spot, so it blindly executed its dance routine directly into the physical space of the table.
Wait, so if I'm understanding this correctly, the company is essentially saying the robot did exactly what it was supposed to do, just in the wrong spot.
That's their stance.
Isn't blaming the lack of space a huge oversight in the design?
Well, if we connect this to the bigger picture, we really have to look at Haidilao's global brand identity. They're pioneers in hospitality technology.
Right, they're known for this stuff.
Their flagship smart outlets in Beijing utilize automated, climate-controlled robotic rooms to prepare ingredients. They use autonomous carts to navigate the dining room floors.
Yeah.
They've built an empire on the promise of blending culinary tradition with cutting-edge, flawless tech integration, which makes a space constraint failure highly ironic.
It really is. It makes this user error defense completely baffling from an engineering standpoint. Wait, let me push back on this technical reality for a second. I am so confused by the hardware discrepancy here. My $200 consumer-grade Roomba vacuum has an array of bump sensors, infrared drop sensors, and basic spatial awareness.
Right.
If it touches a chair leg, it stops its forward momentum, recalculates, and turns around.
Exactly.
How can a hospitality robot, which likely costs tens of thousands of dollars and operates in a high-liability environment, not have the same basic tactile or proximity sensors as a household vacuum?
Well, you're hitting on the critical difference between 2D planar navigation and 3D spatial manipulation.
Okay, unpack that.
Your vacuum relies on a relatively simple navigation system, often utilizing SLAM, or simultaneous localization and mapping. It only has to worry about the two-dimensional floor space.
Right.
A bump sensor triggers a simple binary response.
Right.
Stop driving forward. But the dancing robot involves complex articulating appendages moving through three-dimensional space.
So it knows where its wheels are, but it has no idea where its hands are.
It's exactly the issue. The base of the robot might have LiDAR to navigate the aisles, but the arms are likely running on what is called an open-loop control system.
Open loop.
Yeah. In an open-loop system, the central processor sends a command to a motor joint, say, rotate 45 degrees at this specific speed. The motor executes the command blindly.
Wow.
There is no feedback loop telling the processor, hey, I only made it 20 degrees before I hit a solid object.
Oh.
It lacks the advanced kinematic sensors, like torque sensors or ultrasonic proximity arrays on the limbs themselves, to detect obstacles in real time.
That completely shatters the illusion of artificial intelligence. I mean, if the machine cannot dynamically adapt its physical routine when an obstacle like, I don't know, a table full of boiling soup is in its way, it isn't a smart robot.
No, not at all.
It is just an incredibly heavy, highly dangerous wind-up toy.
That's a great way to put it.
If I am asked to step closer to your table to show you something, I visually process the space. I see your water glass, I register how close my elbows are to your plate, and I restrict my movements accordingly. I use closed-loop feedback based on my environment.
And the human brain processes millions of environmental data points instantly to achieve that spatial reasoning. Programming a machine to do the same requires massive computational load and incredibly expensive sensor arrays.
So they just skipped it.
Haidilao, or their robotics vendor, clearly opted for a simpler, pre-rendered animation approach for the entertainment aspect. The robot was essentially just playing back a physical recording.
Yeah.
But deploying an open-loop physical system into an unpredictable, constantly shifting environment like a busy dining room is a fundamental failure of systems design.
And that hardware blind spot brings us directly to Joanna Stern's analysis in our source material, because she zeroes in on the most alarming aspect of this entire chaotic event.
Yeah, she caught something really important.
When she analyzed the incident, she wasn't focusing on the open-loop arms or the SLAM navigation in the base. She was looking for a very specific, universally mandated piece of safety hardware that was shockingly absent.
She was looking for a visible, easily accessible hardware interrupt. The emergency shutoff mechanism.
A big red button. And this is where the regulatory reality of this story gets alarming. I mean, I don't want to frame a stop button as some mind-blowing new concept, because it isn't. It's the most basic safety standard in the world.
Right.
If you look at any escalator, any factory floor machine, any piece of heavy kinetic equipment, there is a giant, brightly colored switch designed to kill the power instantly.
Always.
If you're putting heavy moving machinery inches away from people eating hot soup, shouldn't a giant stop button be rule number one? It's like building an escalator without the emergency stop at the bottom. Why did the safety compliance frameworks for retail automation allow a heavy, multi-jointed robot to be deployed in a restaurant without a massive, obvious hardware interrupt within reach of the public and the staff?
Well, the regulatory landscape for service robots is currently lagging decades behind industrial robotics. Oh, absolutely. If this machine were operating on a factory floor, occupational safety standards, like the ISO guidelines for industrial robots, would mandate light curtains, physical safety cages, and multiple, highly visible dead man's switches.
Right.
But because this robot is categorized under hospitality and consumer entertainment, it falls into a massive regulatory gray area.
It's essentially bypassing industrial safety standards by wearing the disguise of a novelty waiter, but the physics of its mass and torque are identical to industrial machinery.
And that is precisely Joanna Stern's point. Her analysis grounds this discussion firmly in practical engineering rather than, science fiction.
Yeah.
She notes in the source, quote, "It's not about the robot escaping. It's about what happens in tight, crowded environments."
Right.
She's emphasizing that the risk of service automation isn't some grand, autonomous uprising. The real danger is highly localized, physical, blunt force trauma caused by a regulatory oversight.
But because the dining room is the ultimate edge case for a robot, the environment is the one variable it cannot compute. The layout of a restaurant changes every 5 minutes. A family brings in a high chair, a waiter pulls out a tray stand, someone pushes their chair back to use the restroom. The physical constraints are in a constant state of flux.
And when you drop a machine operating on an open-loop script into a space where the geometry is constantly shifting, those changing constraints immediately turn a fun novelty into a genuine physical liability.
Yeah.
That is why the lack of a hardware interrupt is so egregious. A software pause button, buried 3 menus deep on a touchscreen, is useless when the screen is flailing wildly in the air.
Exactly. The staff members pulling on that fabric strap had no immediate mechanical way to kill the circuit to the motors. They had to fight the machine manually because the engineers prioritized the aesthetic design of the robot over the pragmatic reality of an emergency stop.
Yeah.
You go out to a restaurant to relax, to enjoy the social contract of the space, not to actively monitor heavy machinery to ensure it doesn't cross into your physical bubble.
And that friction is the defining challenge as automation rapidly enters casual human spaces. The motor technology is cheap enough and advanced enough to create entertaining kinetic movement.
Sure.
But the sensor technology and the regulatory frameworks are not yet advanced enough to ensure those movements can safely adapt to the unpredictable nature of a crowded, human-centric room.
So when we synthesize the incident report from California with Joanna Stern's spatial computing analysis, what is the core lesson we are walking away with?
Well, the fundamental takeaway is that hardware integration into human spaces requires absolute physical boundaries, and those boundaries must be enforced by fail-safes.
Right. The dancing disaster at Haidilao serves as a stark kinetic warning for the tech industry. It proves that even when a machine is perfectly executing its pre-programmed code, its lack of environmental awareness makes it inherently dangerous. Novelty tech, no matter how futuristic or brand-aligned it may be, becomes a severe liability. The absolute second environmental constraints change. A physical kill switch isn't an option. It is an absolute necessity for anything sharing our physical space.
And, this incident should fundamentally change how we observe our immediate surroundings.
Yeah.
The next time you walk into a highly automated environment, whether you are sitting down at a tech-forward restaurant, navigating a high-end retail space, or walking through an airport terminal, you're likely going to evaluate those novelty robots through a much more critical lens.
For sure.
You won't just see a helpful automated tray or an entertaining digital face. You will find yourself looking at the kinetic reach of its limbs, wondering where its programmed boundaries end and where your personal physical safety space begins.
So what does this all mean? If a relatively simple pre-programmed entertainment robot can cause this much physical chaos merely by operating a few inches outside of its intended spatial zone, how will human architecture, restaurant floor plans, and the very design of our physical environments need to fundamentally change from the ground up to accommodate the next generation of fully autonomous, free-roaming kinetic machines?
Okay, one question for you. Even if Haidilao claims the robot was not malfunctioning, does this incident highlight a bigger risk of using pre-programmed robots in crowded dining spaces where human safety could be compromised?